Hi, welcome back to the part two of the multiple cash flow model, future value of annuity. Now, in our previous video, or the previous lecture, uh, we discussed how to find the future value of annuity, right? And our example was the graduate school fund. And we tried, basically, we found what would be the future value if we make $800 deposits every month at 6% APR for 5 years, right? So that's an annuity, right? Because $800, a regular amount of or constant amount of $800 is deposited at regular interval of monthly, right? Earning 0.5% every month, right? So that's a typical example of annuity, right? That's exactly the definition of annuity. And the future value is 55,000, right? 816. But that's not the final, that's not the conclusion, right? That's only part of the solution. The reason we did this is to check if we could achieve our target. And our target was 60,000, right? Remember that? Because the graduate school 2-year program would cost, at CUNY, it would cost $60K. So since we were falling about $4,000 short, so we were exploring alternative strategies. And one of those alternatives were increasing the monthly deposit or monthly payment, or finding a bank that pays better interest rate, or extending your timeline by 1 year. And we could simultaneously compare and evaluate and compare those 4 different strategies. And our next question was, although we could, easily tell, well, if you increase the monthly deposit by $50, you got a lot closer to your target, right? You're just still about $700 short. Now, also, if you increase your timeline by 1 more year, right, then you more than achieve your goal. You overshoot the goal by $9,000, right? About $9,127. So our next question was, is there any way you can exactly nail that monthly payment? Yes, of course. You can nail the monthly payment, exact monthly payment. Now, remember in single cash flow model, we solved that base compounding equation. We solved it for 4 different unknown variables, right? So just like that, we can solve this equation, right? In other words, let me get back to we can the future value of annuity equation, we can solve this equation for payment, right? In other words, we have 4 variables here, right? Payment, or, and FVA, right? Now you might wonder, isn't it APR? 4 variables are payment, APR, T, and FVA. Eventually it will be this APR and T, but our relevant rate and N compounding periods are these, right? Monthly rate and 60 months, or 60 compoundings, right? So you need to solve, you need these R and N are relevant variables, right? And later, once we find them, then we can convert it into APR and a number of years, right? So let me switch to Whiteboard, right? And then I'm going to switch to Whiteboard because I need to. Okay. So do you all see this whiteboard? Okay, now let's do this. So the formula is future value of annuities. Okay. Well, we wrote it like this, right? But this is also, with training, you will develop the eye to see, that x equals y times, z equals x times y structure. 1 plus r raised to n minus 1. Okay, that should be all the way here. Close parenthesis over r, right? Now, you remember, what did I tell you in all solving, any equation, right? In all equations, in any situation, solving an equation is basically depending on solving an equation depends on your ability, right? Your keen eye, analytical eye, that can identify z equals x times y structure, right? And of course, not everything is given already in this structure. To identify, to spot this structure, you should, if the given structure of the equation is very complex, right? You should be able to reduce that structure, the complex structure, into this structure. Now, that involves a lot of simplification. You will need to simplify that complex equation, right? Regardless of how many times, right? You must simplify to the simplest form. In other words, reduce it to the simplest form, and the simplest form should eventually come to this, right? Then again, solving, if x is the unknown, solving for x is very simple. It's going to be z over y. Now, then here, can you identify z equals x times y structure? Oh, you might wonder. Oh, I don't see z equals x times, but it looks like z equals x over y. Well, you can look at it that way, but that doesn't help, right? But look, this is already given in, it is already in the structure. If you think about it, it is like payment times, right? One plus r raised to n minus 1 over r, right? Isn't that right? It is already given in this structure, if you think about it, right? This is x, right? This is y. Now think about it. And besides, because in multiplication, right, you can split it any way you want, right? As long as you cannot split this term because this is, one whole term, right? One single whole term, but you can split it either like this times this, or this times this, right? But of course, the other case, like splitting it like this times this, doesn't help us, right? It doesn't help. So because what we want to know is payment. You shouldn't lose the sight, right? You shouldn't lose the perspective, right? We want to solve for payment, so we have to make payment our x, right? So we split it this way. And of course, um, uh, I doubt I doubt there is someone who wouldn't understand this, because uh, if you have, let's say, 8 over 2, right? It's the same thing as uh, uh, it's the same thing as 4 times 2 over 2, right? Isn't that right? Then it's also the same thing as writing, like, 4 times 2 over 2. Isn't that right? And of course, 2 over 2 is 1, so it's going to be 4. Anyway, that becomes, that's why it is 4. So you can break it up like that, right? You can break it up like that. That's the idea, right? Righty. And then we are, ready to solve this for payment, because now it is z equals x times y structure. So solving for payment, what do you need to do? You will need to divide this by this, right? So payment is equals, right? Payment is equal to FVA divided by the thing in the bracket. I'll just call it the thing in the bracket. Now, you all know dividing by something is the same thing as multiplying by the reciprocal of that thing, right? Remember? And the reciprocal, this is a way to write reciprocal, right? You all know what x to the negative 1 is. X to the negative 1 is what? 1 over x. Isn't it right? We did this in a couple of classes back, right? That's 1 over x, right? So we are using that. So that means, well, you're dividing FVA by this. Okay? So then it comes to FVA times this gets very messy. So, but you know the idea. You get the idea. It's going to be R over 1 plus R raised to n minus 1. Okay. All right. So this is how you can solve for payment, right? But don't forget, right? Let me, I just wanted to rewrite it in a neat way, but there's a limitation to how neatly you can do it with a mouse, right? So let me go back to the Excel. So let me go to and so in a neat writing, right? In a neat handwriting. I mean, not handwriting, but nicely typed up here, right? So that's our formula, right? So let's nail, okay? Let's nail it. So here, same scenario, and now this time your target future value is known. It's no longer unknown, right? Our target future value is known, 60K. So this time, payment is the unknown. So using that formula, right, solving for payment, which is FVA times R. Oh, that should be filled in, but I forgot to fill in first, but it should be filled in. But we know what they are, so we can build a formula first, and let's fill in that later, right? FVA times R over, open parentheses, open another one, 1 plus R, there you are, raised to n times 1, close the parenthesis, okay, and hit enter. And of course, nothing, it will say, you cannot divide by 0, right? Because this is not filled in. All you need to do is just copy that, paste here. Now, you're not copying the values, right? You understand? What is being copied is the formula, not the value, right? So so that's basically, right? Formula being copied, right? Now, so we got this, but we got too many decimal places, right? Too many decimals. We don't need too many decimals, right? And we're missing dollar sign. This is, of course, $859, right? 9.968. So that's almost $860. So you just give it dollar sign, and then it automatically takes care of the decimal places, because in accounting, or in dollars, right? When you are using monetary units, generally you don't use more than two decimal places. In other words, in US dollars, or euro, or most other currencies in the world, you have you don't use any lower denomination than cents, right? So it automatically rounds it up to two decimal places. And that's almost close to 860. So when we did this thought experiment, if we did this, a trial and error, through the trial and error method, if you plugged in 860, we would have exactly nailed it. But it's pure it's pure chance that you plug in. You have to start from 801, 802. You try all, and there are even 100 integers, right, between 800 and I'm sorry, almost 60 integers between 800 and 860. Including also not just the integers, but all real numbers, right? Like 80.05, 801.05, or 801.11. Think about it. Trying all these possible numbers, it would take a lot of time, right? And if you just first starting from integers, right, from 801 through 860, it would take 60 trials, right? So that's really waste of time. And even when you got by plugging in 860, let's say 861 take you exactly to 60K. It would be slightly greater than 60K, right? So then the fine tuning, so you have to try 859.01, right? Starting from that 859.02, right? Until you get to, this isn't even, exactly 97, it's 96 something, something, right? It's just rounded. So, trial and error method is very time consuming, right? So, not a very smart way of doing that. So, but we don't have to rely on that. We can nail this. We can exactly nail this. Okay. All righty. So, our next question then. You remember there are 4 variables here, and each of them can be the unknown variable. Then when that there with whichever being the unknown, we should be able to solve for that. So we solved for first future value, and then solved for payment, right? And then the next question is what? Oh, then R. How do we solve for R? The next question is N. How do we solve for N? Right? Makes sense? So then here's the thing. I'm going to show you the formula, because just to save some time on steps of derivation. We don't need to derive, but eventually you will need to know how. But steps of derivation itself is not the goal, right? That's the means, right? You got to know how how to do that, because that's basically uh, the power of your brain that can derive those steps of derivation. Um, but let me get to the let me cut to the chase. So if you're solving for R, now unfortunately in annuity or in multiple cash flow models, there is no single unique mathematical formula to arrive at rate. Okay, so what do? We'll have to use Excel's built-in function, right? Then for n, of course, there's a formula, natural log of something, future value of annuity, right? And it's a little more complicated than the single cash flow model. But let me show you how we do, and if there's no single unique formula for R, for rate, what do we do? We'll have to use Excel's built-in function, right? Now, remember, the insert function, right? I believe I also showed you this in the single cash flow model. So go to, that's basically, the mathematical notation for function, right? F of x, function of x, right? Of course, in math, to write f of x, you have to do really, f, and then in the open parenthesis, and x, close parenthesis, right? That's function of x. Now, we go to the insert function, and you will find when the box opens, this dialog box opens, it's the most recently used functions that you will find in the box. And since recently we used rate, it would come on top. But if you don't see it, if you don't find it, you'll have to go into the financial category, right? And scroll down until you find rate, because rate is the name of the variable we are looking for, right? R, right, rate. So hit OK. And then give it what it's asking for. N, right? N periods, right? So give it 60. And then payment. This is the payment. But here's one thing you have to understand. When you are using Excel's built-in function, basically it's a financial calculator setting, right? And in financial calculator, there has to be a distinction between cash inflow and cash outflow, right? So which one is your cash outflow? Well, this is your cash outflow, isn't it, right? Because you're making this deposit every month in the bank at the end of the month, right? So that's the cash leaving you, going into the bank. So that's cash outflow. And all cash outflows are represented as negative. It doesn't mean it's negative. It just means, it simply means it's cash outflow. So we don't want to. So we can either make this negative, or you don't have to make it negative. You can make it negative, right? you can make A8 negative. So without changing this, because when it is negative, it doesn't look very natural. I mean, in accounting, they all know negative can be expressed by in three ways: minus sign, the negative, right? Or parenthesis, or red font, right? Red font. That's But then again, that's accounting. I mean, without without putting it into a red font or parenthesis, uh, you can. I mean, this looks more natural, and you can simply by making that adjustment in the dialog box in a menu in the dialog box of the function, right? You can turn it into negative. Okay, so then there you go, negative. There is no present value. Next thing is present. There is no present value, right? There is no present value because this is a multiple cash flow model. There is no single lump sum, right? At time zero, right? It's all payment is building to future value, right? And what's the future value? Future value is 60,000, right? We have it there. That's and also in notation here, there is no distinction between future value of annuity or just a single cash flow future value, because this function, right, Excel's built-in function, it should be applicable, universally applicable, so they don't uh, uh, by they don't have separate variable label for future value of annuity. It's just future value. And then next, type. What does that type mean? Type means either ordinary annuity or annuity due, right? Either ordinary or annuity due. Now, the default is annuity due, right? So that means unless otherwise specified, by default, it is ordinary annuity. And think about it. The term ordinary means that's ordinarily what it is, right? So if it is ordinary annuity, you either leave it as blank or enter zero. If it is ordinary annuity, leave it blank or enter zero. So you don't have to enter zero because it's by default ordinary. If it is annuity due, you put one there. You put one. Okay. So now, interesting thing. Why one? You remember the difference between ordinary annuity and annuity due is more compounding, isn't it right? There is one more compounding in annuity due. So that's why you enter one. Okay. So since this is ordinary annuity, you don't have to enter anything. And down there, guess, you don't have to take any guess because when you entered future value, you already got this, right? You already got the result. And besides, we are nailing it. There is no reason for taking a guess. So you enter, then hit OK. See, we got that. And then converting it to annual rate, we already know. This monthly, right? So monthly rate times 12 will put it into annual rate. So voila, we got that. Okay. Now, next, we need to solve that for we'll need to solve that for n, right? So to solve for n, let me switch back to PowerPoint to show you the formula, right? Okay. All right, we're back to PowerPoint. So skip a few slides. All righty. All right. Now it looks quite complicated, but solving for other variables, n in case of n, and in case of r, right? But of course, r, we know there exists. This means there exists, right? No single mathematical process, right? But in n, at least you can solve for n, right? These are the steps of derivations, and basically, it's a little more, it looks a little more complicated than the single cash flow model, but basically, to find n, you'll have to use natural log, right? And so this is the formula, right? You might wonder, what is that? Oh, well, that will come later. We're currently talking about the future value of annuity, but that's present value of annuity, so uh, um, you don't have to worry about it for now. We'll come back to that later, right? So this is the formula, right? So we'll go back to Excel, okay? So for your own reference, write it down so that you can use it later, right? Now, write it. Now, let me switch back to Excel. So what's the formula? I also put the oh, it's not here. That's fine. Maybe I put it down there. But, so the formula is, and we'll have to the formula we're looking for. I mean, the variable we're looking for, the unknown, is n, right? So it will be then natural log of FVA over payment, right, times R. Now, you all know multiplying something to a fraction, right? When you're multiplying something to a fraction, it gets multiplied only to the numerator, right? So doing it like this, you might wonder if yours, oh, isn't it going to get multiplied to A9, the denominator? No, it won't get, right? To make it multiplied only to the denominator, you'll have to put parentheses here, right? But without that, it will be automatically multiplied to the numerator, right? Okay. Now plus 1, again, plus 1, it doesn't get added to E9, right? Everyone understands PEMDAS, right? Parenthesis, exponent, right? Multiplication, division, right? Addition, subtraction, right? It operates in that order. So this gets done first, and then this, and then plus 1. So And then natural log of that, or natural log of then 1 plus r, 1 plus r here. And we know what to expect. We already know the answer. We just want to confirm that the formula checks out, right? So if you enter that, hit enter, and we got 60, right? And then converting it into years, we already know 60 months, then you divide it by 12, right? 12 months, right? That takes you to 5 years. Okay, good. So we nailed also, right? We nailed also the n, right? Now, we could also nail, since I showed you the Excel's built-in function, we can do it also using Excel's built-in function. For example, let's say I don't have this, right? Using Excel's built-in function, right? So let's go to, I just don't want you to rely on that. Let's just go to Excel's built-in function, right? And if you're in the financial category, you scroll down. The variable we're looking for is future value, right? Once again, there's no distinction between future value and future value of annuity in the financial calculator. It's just future value. It's only the different, it's the only thing is the difference in the variables is inputs that are going in there. Hit OK. Then it's first asking for the rate. You enter rate. It's asking for N. There you go. Payment. There's the payment, right? But once again, in the financial calculator setting, right, you have to make one thing a cash inflow and the other thing a cash outflow. And in our context, payment is the cash outflow, right? Because it's leaving your pocket, it's leaving your wallet and going into the bank. Now, there's no present value, right? This is not a single cash flow model. Type ordinary annuity unless otherwise specified. And you got this already, right? So hit OK, you got that, right? And then as you then scroll down, you get, right? Okay. What about this? Yes, you can do it by you scroll down until you find payment. There you are. Hit OK. Give it the rate. Give it N. No present value, but give it future value, right? Ordinary, type ordinary, right? So you don't enter anything or enter 0. And then hit OK. You got this already. Oops, something went wrong. Okay, what did I do? Let me backtrack. Oh, the formula was already in. So you gotta get, because that's positive and then this is gonna be negative. It's gonna be, yeah. Okay. I forgot to delete the formula that was already in there. Hit enter. Oops. And then I forgot to equal sign, right? I have to have equal sign. There you go. We got the but then all these things turn to negative. Why? Because look, previously this was not negative, right? And we made it negative in the formula, right? We made it negative in the formula, right? There you go. So we made, but because it was not negative at previously, we made it negative. So think about it. Now this is already negative, and you make it negative again, then it's going to be positive. So that's why. So you make it, you take out the negative sign, then this will be A8 by itself is already negative. So you get that, right? And then again here, this thing is weird, right? It's negative 86 months. There is no such thing as negative time. Um, so the reason was because A9 was already by itself already negative. So I'll make it negative here, then it's going to be positive, right? Or, we can even, okay, we can solve for that using also built-in Excel's built-in function. So we're solving for n. So it's n periods, right? Hit OK, give it the rate, give it the payment. The payment is already negative, in negative. You just enter it like that. Give it the future value. Type, just leave it blank because it's ordinary. And you see 60 already. Hit OK, you got 60 here, right? So once again, you can solve it either with Excel's built-in function or by formula. But no, I want you to use formula. Why? Because Excel's built-in function is like a GPS. Now, if you rely on GPS, right, when something happens, something goes wrong with GPS, then you become completely an idiot, right? Why? There's no mental map in your mind. There's no mental map. And if you just, so get so used to relying on GPS, what happens is you know the area, you know how to get there, where to make the turn, where to even if you don't know even if you know the area well, you just wait for the prompt from the GPS, like in 500 feet make a left, right? In quarter of a mile make a right, right? Make at the next intersection make a right or make a left. Now the problem is sometimes the GPS prompt is a tad bit too late, just a tad bit too late. Or I mean, GPS, there's a delay. Sometimes when there's a lot of traffic, GPS has a hard time finding you. I mean, if you're going through a multiple interchange, multiple layer interchange, you're on the, like, there are like, 4-story, 4-layer highway interchange, and you are at like a second level, the GPS thinks that you're on the fourth level or third level or on the bottom, level, and then it misdirects you. There's no exit in the second level, but in other words, there are so many cases where GPS can go wrong. For example, waiting for the prompt. You have to make the right turn, but sometimes waiting for the prompt is a bit late, and you have already past the intersection, you cross the intersection, then it's saying make a right. Or in the middle of crossing the intersection is giving you that cue, make a right. It's too late, right? If you make that right turn there in the middle of the intersection, or as you already, unless you get into an accident because you're making uh, an abrupt, very abrupt, sudden right turn. The car behind you will hit you, right? So that's the downside of relying on GPS. You become a complete fool. You become an idiot, right? You know uh, you have to make a right, but you're waiting just for the and sometimes you're completely your brain, your mind is completely devoid of that mental map. You got so used to, right? So you when something goes wrong with the black box, or when something goes wrong with the GPS, you can't fix it, right? If the satellite is fried, right, hit by an asteroid, the GPS goes off, all right, or it may give you a wrong direction. That's the same thing. If you rely on the Excel's built-in function, right? If something goes wrong with Excel, or if something goes wrong with the Excel, then it's totally will be an irreparable situation. But if something goes wrong with the built-in function, you can't fix it, right? But by using the formula, right, uh, you can overcome some glitch in the built-in function. All right, so that's it for this lecture. Uh, so I will see you in the next class, and we're going to continue on with the present value of annuity. Okay. All right. End of video. Stop sharing and stop recording.